Micropitting typically occurs in gears at a contact pressure of between 0.5 and 1.5 GPa and at slide roll ratios from approximately 0, the gear pitch point, and up to approximately 10%. Conventional micropitting rigs typically have a rod sample loaded between 3 supporting rollers, which are driven at different speeds to generate constant slip. Such rigs are usually expensive and require 1 test roller and 3 driving rollers per test. By comparison, micropitting tooling on a reciprocating rig can use simple, inexpensive samples and provide continuously varying slide roll ratios, as happens in actual gear contacts. The T55 is derived from various slide roll adapters available on our standard T77 reciprocating tribometer. In this design, a pair of 20mm diameter rod samples are loaded against plate samples which are mounted on either side of a reciprocating assembly. The maximum reciprocating stroke is 8mm and the minimum stroke is 2mm. Carriers on top of each rod sample provide locations at varying pitch circle diameters for driving pins. These engage with slots on a driving plate on the reciprocating assembly. For a driving pin located at a 20mm pitch circle diameter, the motion of the roller at mid-stroke will be pure rolling, with increasing slide roll ratio towards the end of the stroke. The motion is thus similar to a gear tooth contact, rolling and sliding about the pitch point. Reducing the stroke to 2mm generates a contact with microslip, resulting in a model of the kind of fretting motion observed in bearings. It's possible to make small adjustments to the crank radius of the driving pin to values of PCD plus or minus 1mm. In this case, the slide roll ratio at mid-stroke is not 0, but note that the sliding at the mid-stroke position will be in opposite directions, depending on whether the crank radius is greater or lesser than the PCD. This example shows a test run at 4mm amplitude and 10 Hz with PaO4 as the lubricant. The contact pressure was 1 gigapascal. After 600,000 reciprocating cycles, in other words 1.2 million fatigue cycles, the specimen surfaces look like this. After 1.5 million fatigue cycles, they look like this. At the stroke ends, where the slide roll ratio reaches a maximum, micropitting gives way to plastic deformation and sliding wear. Reducing the stroke amplitude to 1mm allows us to run fretting tests. In this case, we're looking at 2 different greases running at 10 Hz and a total stroke of 2mm. The tests were run at 0.75 gigapascals for 200,000 reciprocating cycles, generating 400,000 fatigue cycles. Comparing the two rolling element test specimens, the grease used for the right-hand test resulted in much more wear and fretting than that for the left-hand test, with significant evidence of a build-up in oxide debris. For more information about this rather novel test device, please contact Phoenix Tribology direct.